Alright, Math 1, Sequences, Practice All. So let's take a look and see what you got. Now, you should be using this to check your work, because if you're just copying it down, it's not going to help you at all. So in these first problems, we're deciding if the sequence is arithmetic, geometric, or neither. So remember, with arithmetic, we grow by addition or subtraction. With geometric, by multiplication or division, and neither would be a different kind of pattern. Okay, and also remember, with arithmetic and geometric, it's by the same number each time. Okay, so usually when I'm looking at a sequence, what I like to do is decide, I'll try to determine if it's arithmetic first, because that's the easiest one to check. So the first thing we want to do is see if addition will work, or subtraction. So 2 to 12, we would add by 10. If I add by 10, will that give me to 72? Definitely not, so I know it's not arithmetic. Okay, so then let's try geometric. So what times 2 would give us to 12? Now, if we didn't know that, you could just take this one and divide it by that, and that would give you the number that it would multiply by. So, timesing by 6. So now I check to see if I'm timesing by 6 each time. So 12 times 6 is at 72. It is. Times 6 is at 432. It is. So I know that this is geometric. Okay, number 2. Negative 1 to 1, then to 4, then to 8. So let's try addition first. Negative 1 to 1, positive 1, we'd add 2. 1 to 4, we'd add 3. 4 to 8, we would add 4. 8 to 13, we would add 5. So you may think, well, that's, there's a pattern there in the addition, but it's not an arithmetic pattern because these numbers are changing. So we know it's neither. Okay, number 3, 1 to 9 to 17. So we could add 8. If we add 8, does that get us to 17? It does. 8 again gets us to 25. It does. Hence, this is arithmetic. Okay, number 4, 18 to 10. We could subtract 8. 10 to 6, subtract 4. 6 to 4, subtract 2. And then subtract 1. So once again, it looks like it could be arithmetic, but it's not because you're adding by, or subtracting by different numbers. So it's neither again. Looking at 5, negative 38, negative 28, negative 18, we should realize we are adding 10 each time, making it arithmetic. And number 6, negative 4, negative 16, negative 64. Okay, we could be subtracting, not adding, subtracting by 12, but if we try to do that, it won't get to 64. So it's not arithmetic, so let's try timesing. Well, 4 times negative 4 would be negative 16. Times 4 would be negative 64, so we can check that and see that this one is geometric. Now, for the next 4, all we need to do is figure out what the pattern is and just continue it. Okay? So knowing if it's arithmetic or geometric is helpful, but basically you're just finding the pattern and completing it. Or at least going with the next 3. So 30 to 24 to 18 to 12. Hopefully we can see that we're subtracting 6 each time. So minus 6 would be 6. Minus 6 would be 0. Minus 6 would be negative 6. And that one's complete. If we look at number 8, negative 12 to negative 4 to positive 4 to 12. Well, 4 to 12 we'd be adding 8. Negative 12 to negative 4 we'd add 8. So we're adding 8 each time, so I'd get 20, 28, and 36. Number 9, 1 to negative 5, and then negative to positive. So I know right off the bat it's not arithmetic. So let's try geometric. So 1, I could times by negative 5 would give me negative 5. Negative 5 times negative 5 would give me positive 25. So this is the right path. So we'd go 125, negative 125 times negative 5 would be positive 625. Then times by negative 5 would be a negative 3125, 3,125. And then times that by a negative 5 would get us a positive 15,625. So geometric there. Number 10, negative 4 to 20 to negative 100. We can kind of see that same pattern of positive to negative. So we'd have to times by a negative 5 to get this to work. So we'd get a negative 2,500. Then we get a positive 12,500. And a negative 62,500. Alright, now 11 and 12 want us to find that common difference. Remember, common difference is basically how is it growing arithmetically. So we just find how is it growing. Negative 34 to negative 31 to negative 28. Our common difference is positive 3. We're adding 3. 12, so it's negative 10, negative 19, negative 28, negative 37. We're adding 9 each time, so our difference is a positive 9. Okay, now 13 and 14, common ratio, that's geometric, so that's the number we're multiplying by. So negative 2 to positive 6 to negative 18, our common ratio would be a negative 3. And number 14, negative 2 to negative 10 to negative 5, we're multiplying by a positive 5. So our common ratio would just be a positive 5. Alright? So those ones should be pretty simple. Now let's get going with some more complex ones. Finding those recursive and explicit formulas. Okay? So remember, with recursive, our format is always the same. We always go a sub n equals a sub n minus 1, and we like to start at a sub 0. Now we could start at a sub 1, but it's a better habit to be starting at a sub 0. Okay? But in all our, when we're just given a list of numbers, that first number is always going to be just our first term. So that's like a sub 1, but we usually want to go back to a sub 0 because it's helpful with other things. Okay? So these parts are always the same. Then we just put our growth here and our starting number. So our start and our growth. So what we need to find is that growth, okay, and where it's starting. So first, let's find the growth. So 24 to 4 to negative 16 to negative 36. So it looks like we're subtracting 20 each time. So if we're subtracting 20, we need to go back to the 0 term, because 24 is the first term. So going back to the 0, we do the opposite and add 20 and get 44. So our starting number, so we go a sub 0 equals 44, because we need that part in there. Then the growth would be minus 20, so I'd go a sub n equals a sub n minus 1 minus 20. Okay, and that n minus 1 is a subscript of the a, as well as that n right down there. Okay, and you have to have both pieces. If you don't have both pieces, it's an incomplete formula, and it won't quite get you what you need. Okay, so looking at 16, negative 7 to negative 12 to negative 17, we are subtracting 5 each time. So going backwards, it would be negative 2. So a sub 0 equals negative 2, and a sub n equals a sub n minus 1 minus 5. And there's our recursive formulas for an arithmetic formula. Once again, notice that this part is always the same as is this part. Okay? And it's a good idea to write them kind of a little bit lower for the n and the n minus 1. Remember, the recursive formula connects the outputs. So it's the next output equals the previous one, and then whatever the growth is, and then the a sub 0 is where we started. Okay? So if we look at 17, negative 3 to negative 15 to negative 75. So we're definitely not adding by 12, which is what we need to add by. Okay. Instead, we're going to have to be multiplying. So 3 to 15, we would times by 5, which if you need to, you can double check that. So if we go backwards, this one can be the tricky one. So the opposite of multiplication is division. So I'd go negative 3 divided by 5, which I just leave as negative 3/5. So a sub 0 equals negative 3/5. Then a sub n equals a sub n minus 1 times 5. Okay, for number 18, negative 3 to negative 12, we would times not by 6, by 4, which would get us to negative 48, which would give us to negative 192. So, going backwards, it'd be negative 3 divided by 4, so I could just leave it, negative 3/4. Then I do a sub n equals a sub n minus 1 times 4. Now notice, a sub 0 on all these, whether they were geometric or arithmetic, same thing, same with the rest of them. Just that growth, which was different. Okay. Now for the explicit formulas, okay, remember these ones, and I'm going to clear some space here. For explicit formulas, okay, now we're connecting an input to an output. So we just go a sub n equals, and we usually do our starting number, and then plus or minus or multiply our growth. Okay, so once again, we need to know that start number and our growth. Okay, and that's why it's a good idea to deal with the a sub 0 and not the a sub 1, because it makes it easier when we're writing these equations. So 40 to 10 to negative 20 to negative 50, looks like we're subtracting by 30. So going backwards, we would add 30, and we'd get to 70. So our start number is 70, our growth is negative 30. So we go a sub n equals our start number, then we're going to subtract 30, and because we subtract over and over and over, the repeated subtraction is multiplication, so I times by n. Okay, so 20. 2 to 11 to 20 to 29, looks like we're adding 9 each time. So going backwards, 2 minus 9 would be negative 7. So I go a sub n equals my starting number, negative 7, plus 9 times n. Because they're arithmetic, okay, that repeated addition we show through multiplication. Alright, 21. 4 to negative 8 to 16 to negative 32. So we times by a 2, and it'd have to be negative to make it go positive, negative, positive, negative. So if I'm going backwards, I divide by negative 2, which would give me negative 2. So I'd get a sub n equals negative 2 times negative 2. Now, because we're going to just do repeated multiplication, the shortcut to that is a power. But notice, same idea. Okay, 22, 4 to 16 to 64 to 256. We're times them by 4 to get this one to work. So if I go backwards, 4 divided by 4 would be 1. So we start at 1. So I go a sub n equals 1 times my growth. Because it's multiplication, I put my variable at the top. So notice, same idea. Start number, start number. Okay, a sub n, a sub n. Then minus or plus, because it's arithmetic, and down here times, because it's geometric, and here, because the repeated addition or subtraction is multiplication, it's times n. Because repeated multiplication is a power, it's to the power of n. Alright, so let's take a look at the next ones. Now, for these ones, we're going to kind of go different, okay? So now I've given you the recursive formulas. Notice they've got two parts. Notice here, they gave us the a sub 1, which that's alright. We can work with that too. Okay, and so we want to find the common difference, so it's growth. Because these are arithmetic, we call it common difference. The first 5 terms, and then also the explicit formula. Okay, so I'll show you, be able to show you why this a sub 1 isn't as useful as a sub 0 when talking with the explicit formula. Okay, so first things first, the common difference should be easy to see. it's plus 5, minus 30, minus 2. So I go d equals positive 5, d equals negative 30, and d equals negative 2. Then the first 5 terms. Okay, so on number 24, I kind of show it in table form. On the others, I won't because of the space. But a sub 1 equals negative 9, so I start with negative 9. Then I add 5 each time. So negative 9, negative 4, positive 1, positive 6, positive 11. There's our first terms. Okay. On 25, we start at negative 35, and we subtract 2 each time. So negative 37, negative 39, negative 41, and negative 43. If I wanted to do it in table form, okay, starting at 35, and then we subtract 30. So this would be 5, negative 25, negative 55, and negative 85. Okay, but like I said, remember that's our first, second, third, fourth, and fifth terms. Okay, normally when we do the explicit formula, we want that 0 term. And the reason being is because if we look at this one right here, if we start, because the explicit connects the input and the output, if we start subtracting here, then I'd go 35 minus 30 would give me 5. Okay, but that's the second input. So that means I add once or subtract once instead of subtracting twice. My inputs are supposed to match how many times I've added or subtracted. Okay, and so if you're using this a sub 1, what you have to do is you have to account for that. Okay, because this isn't our first one, we need to drop it back to get our first one. So I'd go a sub n equals my starting number, which I could write 35 if I really wanted to. Then I'm subtracting 30 each time. But instead of going n, I would have to go n minus 1 here. Okay, because we have to take it back one time. So, if I wanted to, I could then distribute that through and simplify it. And I'd get 35 minus 30n plus 30. And I'd end up with, combining like terms, I'd end up with 65 minus 30n. Okay, would equal a sub n. Which, if we went backwards here, that's what our 0 term would be with anyway. So, that's why I say I usually think it's easier to go back to the 0 term. Because if I would have just written 30n here with the 35, that wouldn't be the correct explicit formula for this. Okay? So it should actually be that 65 minus 30n. So thinking about that, it's a good idea to go back here one, and so we'd subtract 5, so it would be negative 14. So I'd go a sub n equals my start number, negative 14. Then we're adding 5 each time, so plus 5n. And 25, I'd take it back to the 0 term by adding 2, so it would be negative 33 for my a sub 0, my true start number, and I'd go a sub n equals negative 33 minus 2 times n. Okay, make sure when it's arithmetic that when you're writing your growth, you don't write it up high, you write it right next to. May not seem like a big difference, but it is. Okay, because of that idea of the multiplication and powers and the repeated addition and multiplication. Alright, so now 26, 27, and 28, same idea. Except this time we're given the explicit formula and we want to find all this information and the recursive. Okay, so what we need to understand is that the starting number here, okay, is the 0 term. So recursive would be easy to start off. A sub n equals a sub n minus 1. I can see my growth, it's the number with the variable, so plus 10. Then a sub 0 would equal negative 37. Okay, so that plus 10 is my common difference, so d equals 10. And then I start one past that for my first 5 terms. So if I go negative 37 plus 10, that would be negative 27. Then negative 17. Then negative 7, positive 3, and 13. Okay, so 27. We've got that minus 10. So our common difference is a negative 10 this time. If I'm starting at negative 10 and I minus negative 10, so that's like my a sub 0 is negative 10. So then my a sub n would equal a sub n minus 1 minus 10. And for my terms, I'd start out, that would be my 0 term, negative 10. But I actually want to start at my first term, so I'd subtract 10 from that. I'd start at negative 20, then negative 30, negative 40, negative 50, and finally negative 60. Okay, because we have to understand the difference between the a sub 0 and the a sub 1s, okay, and how we use those. So the last one, common difference would be a negative 3 here because we're subtracting 3. I would start at 26, but that would be my a sub 0, so if I'm just doing my list, I would subtract 3 and start at 23, then 20, then 17, 14, and 11. For my recursive formula, a sub 0 equals 26, then a sub n equals a sub n minus 1 minus 3. Alright guys, there we go with that. Now, we're going to do the same process but with geometric. So the only difference here is we've got multiplication and powers instead. So, we're times them by 6. So, if I start with 4, or my common ratio would be timesing by 6. Then I would start out at 4 times 6 is 24, times 6 is 144, times 6, 864, and one more, times 6, 5184, 5,184. Now for my explicit, once again I have to kick it back to the 0 term, or if that becomes too troublesome, you could do the n minus 1 version, okay? Because if I go 4 divided by 6, that would become 2/3. So I could go a sub n equals 2/3 times 6 to the n. Notice I bumped it up here because it's repeated multiplication. If you didn't like that fraction, I could go a sub n equals 4 times 6, but I have to just remember to, instead of n, I go n minus 1. These two formulas are the same thing. So sometimes it's easier to do that n minus 1 on these guys. So 30, my common ratio is 3. Okay, then we're starting at negative 4 times 3 would be negative 12 times 3, negative 36 times 3, negative 108. So yes, I double checked it. It is negative 108 and then negative 324 for our fifth term. Okay. Now to do our formula, I can do the a sub n equals the first term, not the 0 term, negative 4 times 3, but then I take it back to the 0 term in my n minus 1. Or I could have physically went back. I want negative 4 divided by 3. I want a sub n equals negative 4/3 times 3 to the n. I accept either one. Okay, then 31. My growth, r equals 2. Okay, starting at negative 2, negative 4, negative 8, negative 16, negative 32. Could go back, negative 2 divided by 2 would equal negative 1, so that's a little bit easier. So I could go a sub n equals negative 1 times 2 to the n, or a sub n equals negative 2 times 2 to the n minus 1. Once again, either one works. Alright, now let's do an explicit formula. And notice these ones are all doing the n minus 1, so that tells me right off the bat that that's a sub 1. Okay, so my common ratio, number being raised to the power, so times 5, negative 6, and positive 4. And then starting with the first term, 4 times 5 is 20, times 5 is 100, times 5 is 500, times 5 is 2500. Okay, for 33, a negative outside really means negative 1. So negative 1 for my first term, positive 6, negative 36, positive 216, and negative 1296. Then 34, we start at negative 2 and we're times them by 4. So negative 8, negative 32, negative 128, and finally negative 512. Now to go to the recursive, I could, just like up here where it had a sub 1, I could go a sub 1 equals 4, and a sub n equals a sub n minus 1 times 5. And that would be an easy way to do it, given the information we already have. Okay. However, if I really wanted to, I could instead decide that I wanted to make these a sub zeros instead, which if that were the case, I'd go a sub 0 equals, and I would kick it back, so it would be 4/5, or the decimal equivalent. I would kick it back here, and it'd be a positive 1/6, and here it would be a negative 2/4, which is a negative 1/2. So there is some latitude that you can use when you're dealing with those. Alright? Alright, now this last one, let's just see if we can understand what's happening here and figure out what the missing terms are. Okay? So these first four are arithmetic, so we know we're adding. So if I go 32 to something to 52, well, we went up by 20. So cutting that in half would be, we should probably be going up by 10, shouldn't we? So that would be 42. Negative 20 to negative 420. We went up by 400, so cutting that in half would probably be negative 220. 12 to negative 388. Okay, that one's a bit tougher. We'd actually be going down by 400. So it would be negative 188. And looking at 38, negative 29 to negative 41, we would be going down by 12. So cut that in half, we'd be going down by negative 6 each one. I'm cutting it in half because this represents 2 jumps instead of just 1. So it would be negative 35. Okay, now geometric, what are we multiplying by? So 1 to 9, I'd multiply by 9. Well, 9 is what times what that's the same? It would be 3, right? So I'd be times them by 3 each time. This one, same idea, 1 to 4, and times them by 4 in one jump, but I need it in 2 jumps, so that would be 2 times 2, so it would be 2 here. 4 to 16, times them by 4, so it would be 8, because we'd cut it into 2 times 2. 4 to 100, times them by 20. Nope, by 25. And 25 is 5 times 5, so for the one jump, that would be 20. Now these last ones are pretty tricky, because how do you do it if you're doing it with more? So the idea is I need to find the difference in this, and then because I have 1, 2, 3, 4 jumps, I need to split it up into 4 different plus numbers. And that's the process for each of these. So the idea is the difference between 12 to negative 108 is a difference of 120. So if it's one jump, it's 120. If I split it up into 4 equals, I divide by 4 to get my number. So that's the same process I want to do on all of these. And actually this should be minus, because that was a minus, because I went positive to negative. So I get negative 18 to negative 48 to negative 78 to negative 108. So you can kind of follow along and see what I got here. Now, when you're dealing with the geometric ones, and there's more than one, it's quite a bit more difficult. So I'd actually take this 250 and figure out what number did I multiply by to get there. Then I cut it into 3 pieces, what times what, 3 times, to get my answers. So 250 divided by 2 would give me 125. 125 cut into those 3 pieces would be 5, so I'm times them by 5 each time.